Well, hello there. We're going to do some multiplying powers with the same base. So we're still working with some exponents here. I'm going to get us started on problems 1 through 8 to kind of see what's going on because we're looking for a shortcut, and this is kind of a proof for it. So for like number 1, we have 2 to the second power times 2 to the second power. So really that's 2 times 2 times 2 times 2, which is 2 to the fourth power. And we can see that as 2 to the second power plus the other exponent plus 2 to the second power, and that's where I get my 2 to the fourth power. If I look at the next one, it's 3 to the second power times 3 to the second power, and that's really like 4 threes, which is 3 to the fourth power. So it's like taking 3 to the second power from our first one and getting our second exponent from the other one. And for the 3, it's 3 to the third power times 3 to the second power. So that's like 1, 2, 3, 4, 5 threes, so it's 3 to the fifth power. But if I just look at the original exponents, it's 3 to the third power plus 3 to the second power. I add my exponents and I end up with 3 to the fifth. I'm going to press pause, and why don't you work on 4 through 8. All right, as I run through each one of these, I'm actually creating something called a power rule for exponents. And we're going to talk about that in a moment here, but if they have the same base, I can just add the exponents. And that's the pattern that we have found. If they have the same base, we can add their exponents. We're going to look at another pair here, kind of same concept here. But we're going to introduce these negative exponents. Now remember, the negative exponent doesn't mean it's negative, it just means that it's small. So 2 to the second power is 2 times 2. 2 to the first power is equal to 1 over 2, so that's half. So we have 2 over 2, and half of this 2, which is 1, I'm left with 2 to the first power. And if I utilize my other rule, my rule power with exponents is going to be 2 to the second power plus my negative 1. 2 plus negative 1 is 1. Let's check that out with number 11. 2 to the fourth power, so that's 1, 2, 3, 4. 2 to the second power, which is 2 halves. Okay, and if I work this out, I've got a couple of halves here, which make like half of this, which is 1, half of that, which is 1. So I'm left with these two 2's. So it's 2 to the second power, and we can see that here. 2 to the fourth power plus the negative 2. So it looks like I can add the exponents again. Why don't you press pause, try 12 through 15, and see if we are doing the same thing. All right. Looks like our power rule is still working through these, no matter if my exponent is positive or negative. Interesting one for 13 is I end up with 4 to the 0 power, and anything to the 0 power is 1. There we go. Okay, you can write a product of powers with the same base, such that 3 to the fourth times 3 to the second using one exponent. So if they have the same base, you can go ahead and add the exponents, 4 plus 2, to get 3 to the sixth power. And we're going to utilize this here, but the main thing is you got to be looking for the same base. So I have the same base, which is 12, and I'm going to go ahead and add the exponents. So 4 plus 3, and I'm going to end up with 12 to the seventh power. This guy over here, same base of negative 5. And I'm going to go ahead and I'm going to add my exponents, so negative 2 plus the 7. And I end up with negative 5 and 7, 6, 5. So I have negative 5 to the fifth power. Now notice if these were negative 5 to the negative second times 5 to the seventh, I could not use this rule, this product rule, because they are not the same base. So careful, one of the main things is they have to have the same base. All right, I've got it here. Once you press pause and you try it out. Again, look for same bases. Good luck. All right. How'd we do? How'd you do? I'm feeling good. Hope you're feeling good. Just getting comfortable with these rules here. All right, when variable factors have more than one base, so something you have to keep on, be careful to combine only those powers with the same base. They got to have the same base. So really, when I see 4 times z to the fifth times 9 times z to the 12th, this really is saying 4 times z to the fifth times 9 times z to the negative 12th. So I'm going to be looking for my common bases to multiply together. So I have the coefficients. 4 times 9, which is 36. And then I'm going to look at my bases and use my product rule here. I have the same base of z, and I'm going to take my exponents and I'm going to add them together. So I end up with 36z, 987, 36z to the 7th power. Is that right? Oh, it's negative 7. Yeah. Okay, so now this changes things a little bit, because remember, we don't really want to leave that alone like this. You can also write this as 36 over z to the 7th, because a negative exponent doesn't mean it's negative. It just means that it's small, or little, as I like to say. Another problem here, I'm going to go ahead and multiply my coefficients of 2 times 9 times 3. And 2 times 9 times 3, what's that, like 36? No, it's 54. So it's 54. And then I've got, what do we got here? I've got a couple a's. So I've got an a here and 2 a's there. So it's a to the first, which is right there, plus the 2. And then I've got a b to the 4th. And then I use my product rule to pull it all together. That's a to the 3rd and b to the 4th, and I could write 54b to the 4th and a to the 3rd. All right. Ooh, looks like we got some for you to try. Yippee! All right, press pause. Give it a rip. All right, this is what each one of them looks like, combining the terms using my product rules. Just one of the things you want to keep track of is a fully simplified exponent. If there's a negative exponent, you move it into the denominator, showing it as a value of something that is small. Small. Okay, absolute value. No, not absolute value. This is scientific notation. Scientific notation uses exponents. Excuse me. I have a decimal starting off times 10 to a certain power. Now the key with this for scientific notation, excuse me while I cough for a moment, or maybe 6 minutes, maybe 12, maybe tomorrow. All right, no, I'm okay. Thank you for asking. All right, for the first part in scientific notation, this number needs to hang out between 1 and 10. So if you end up with an answer that is not between 1 and 10, too small or too big, then it is not in scientific notation, but you can modify it, adjust it around. You just need to change your exponent. So we're going to go ahead and try this one. We've got a problem here where we have multiplying with scientific notation. Now these two problems here, we've got 1.13. Where we got some different numbers here. Okay, so our big problem on this whole thing, let's see, so we have 1.13 times 10. Whoa, that's little. Is that like a negative 3? I think it is. Negative 7. That's like a negative 7. Holy smokes, that's teeny tiny. That times 9.98 times 10 to the 5th times 3.34 times 10 to the negative 22nd. Okay. Sorry, I was really distracted there. A panda came in my room and I just couldn't help myself. The thing was so cute. I had to like cuddle with it for a little while, but I'm back. So I'm good. Where were we? We were like doing like scientific notation and multiplying. Hey, so this is kind of the same thing. It's like these coefficients right here. So it's like 1.13 times 9.98 times 3.34. I'm going to take all of those times, and look at this. I've got all these bases that are the same, 10, and we're multiplying, so I can just take their exponents and add them together. So negative 7 plus 5 plus 22. I'm going to go ahead and use a calculator of sorts here, and all these decimals multiplied together get me like 37.7, right around there. And then it's going to be times 10, and that's negative 7 plus 5 plus 27. I end up with like 20. Now the deal is 37.7 is not between 1 and 10, so I need to move my decimal over. So now it's 3.77 times 10, but I need to adjust my exponent. I need to adjust it up 1. So what happened is when I move my decimal to the left, my value of my exponent goes up. And the same thing happens, like if I have to move my exponent, because that could happen, if I have to move my exponent to the right, my exponent goes down in value to match the movement. Excellent. All right. I'm going to go find that cute little panda and, I don't know, see if he'll play cards with me.